Welcome all. Now I am going to discuss question number 48 from the GATE 2020 paper Electrical Engineering. The question is windings A, B, C have 20 turns each and are wound on the same iron core as shown, along with winding X which has 2 turns. The figures show that sense clockwise or anti-clockwise of each of the windings only and does not reflect the exact number of turns. If windings A, B, C are supplied with balanced 3-phase voltages at 50 Hz and there is no core saturation, the no-load RMS voltage in volts rounded off to 2 decimal places across the X winding is. To know the detailed modeling of single phase transformers, audience can go through the given NPTEL video link. Let us discuss some useful information to solve the problem. Transformer is a electromagnetic circuit that couples primary and secondary winding with a magnetic circuit. Means the two windings are electrically isolated and magnetically coupled. Because of the current flow through the primary winding, EMF is induced across the primary winding because of the Faraday's laws of electromagnetic induction, and it is given by Vp is equal to Np into d5 by dt. Here Vp is the induced EMF in the primary winding, Np is the number of turns in the primary winding, d5 by dt is the change in the magnetic flux. Then because of that the core will be magnetized in nature and EMF will be induced in the secondary winding according to the Faraday's law of electromagnetic induction, and it is given by Vs is equal to Ns into d5 by dt. So by taking the ratio of two equations, Vp by Vs is equal to Np by Ns. For a ideal transformer, if the transformer has no magnetizing losses and the resistance or reactance losses in the windings, we can say that power supplied is equal to the power delivered by the transformer. So P in is equal to P out. So P in is voltage into current in the primary winding. P out is multiplication of Vs and Is in the secondary winding. By taking the ratio Vp by Vs, which is equal to Is by Ep. So by comparing this equation and this equation, we get Vp by Vs is equal to Np by Ns is equal to Is by Ip. So using this equation, let us solve the problem. First, given data. What it is given? ABC windings are 20 turns each and X winding is 2 turns. If we carefully observe this circuit, C and B windings are turned in clockwise direction and A winding is anti-clockwise direction. So this is negative polarity to the B and C windings. Means the voltage supplied is, this one is positive and the A is clockwise direction. So this is also plus. So with the secondary winding, B and C are aiding in nature, A is opposing in nature. So the total voltage supplied by the source is minus VA plus VB plus VC. So minus VA means minus 230 at an angle 0 plus 230 at an angle of minus 120 plus 230 at an angle of plus 120. So minus 230 plus 230 we can take it as common. So cos minus 120 plus j sin minus 120 plus cos 120 plus j sin 120 degrees. So after further simplification we get minus 230. This sign of minus as minus sign, right? So this component and this component will cancel each other, and cos of minus 120 is cos 120 degrees. So 230 into 2 into cos 120 degrees. We know that cos 120 is minus 0.5. So minus 230 degrees minus 230 degrees, that is minus 230 minus 230, which is equal to minus 460 volts. This is the amount of voltage which is supplied by the source. So we know that transformer ratio Vp by Vs is equal to Np by Ns. Primary winding is source voltage. Just now we found out, that is minus 460 divided by secondary winding voltage we need to find out, and the primary number of turns are 20, secondary number of turns are 2. So V secondary winding is equal to minus 46 volts. So this much of EMF will be induced. This is the no load RMS value of voltage at the secondary terminals of the transformer. So the no load RMS voltage is 46 volts. Thank you.